Good morning, all. Welcome to my channel Vijay's Physics Sprint. Today we'll discuss about a meterbridge concept. Meterbridge, it is nothing but the practical application of Western bridge. Last class we discussed about the Western bridge. So the practical application of Western bridge, it is called as meterbridge. So in wisdom bridge, it consists of four resistors connected in quadrilateral shape. When current through galvanometer is zero, that is Ig is zero, then we are achieving the balanced condition. What is the balanced condition we achieved in wisdom bridge is P by Q equal to R by S, or R1 by R2 equal to R3 by R4, the four resistors. Same, the meter bridge also works on principle of Western bridge. Balanced condition when current through galvanometer is 0, then we are achieving the balanced condition P by Q equal to R by S. Based on this principle only, the meter bridge will works. See the diagram, the experimental setup of the meter bridge. See, this is a wooden plank. It's a completely wooden plank, right? And the manganese wire is a manganese wire fixed between on meter scale. Meter scale length, it is 1 meter, nothing but 100 centimeter. On the scale, manganese wire is fixed between two supports. Why only manganese wire? Because the resistance of this wire, it is independent on temperature. Means if temperature rises or decreases, the resistance remains same. No change in the resistance of this manganese wire, so that the manganese wire fixed between two fixed supports, and its alpha value is 0 for manganese wire. The temperature coefficient of resistivity alpha, temperature coefficient of resistivity alpha is 0 for manganese. So no resistance change when temperature fluctuations, right? Now see the diagram. So these are copper strips, right? So these are the copper strips are connected, one gap, left gap, and one more is right gap, and connected to copper strips. Left gap is connected with unknown resistance X. We have to calculate the unknown resistance by using of this meter bridge. Unknown resistance connected in left gap, and the known resistance connected in right gap. This is the resistance box. We can arrange the resistance 1 ohm, 2 ohm, 5 ohm, 10 ohm like this. So these are the known resistance. The known resistance value in right gap, unknown in left gap. And from middle is a galvanometer to detect the current in the circuit, and connected to jockey is J. Jockey is used to determine the null point. Null point means when current through galvanometer is 0, the particular length it is called as null point, and corresponding length it is called as balanced length as L1, right? Total length it is 100 centimeter. For example, at this point the current through galvanometer is 0, nothing, balanced condition is achieved. Corresponding point is null point, length it is balanced length L1, and the remaining length becomes 100 minus L1, right? So this is the value of L2. The other length L2 can be written as 100 minus L2, right? And this is a power supply. This is power supply, and connected to is a plug key. This is the experimental setup of this meter bridge. See how we are calculating this unknown resistance value. See, the unknown resistance connected in left gap, and the known resistance in right gap. Galvanometer, by using of jockey, null point is identified, okay, and length it is L1 and remaining length it is L2. Right, I am applying the Western bridge condition. What is the Western bridge condition? That is P by Q equal to R by S. Right, so this is the length L1 and this is length it is L2. We know that the resistance is directly proportional to length of the wire, length of the conductor. So the resistance of corresponding length it is taken as P and other portion it is taken as Q. So P proportionally to L1 and Q proportionally to L2. Substituting here, right, P proportional to L1 and PQ proportionally to L2 and PQ, and this is unknown as X and this is known as R. L1 by L2 equal to corresponding resistance is X and this is corresponding resistance it is R. We need the value of X, so X is equals to R into L1 by L2. But what is the value of L2? L2 can be written as N100 minus L1. So X becomes R L1 by 100 minus L1. So this is the resistance of the given unknown resistance value. X is equals to R L1 by 100 minus L1. This is the unknown resistance, calculation of unknown resistance by using of this meter bridge, right? And how we are calculating the specific resistance? Specific resistance or resistivity. Resistivity, rho. So we know that resistance R equal to rho of L by A, then rho becomes R into A by L, or also written as R into area, cross section area of the wire, it is pi R square L. R is a resistance, already we calculated the unknown resistance value, right, substituting here, then rho equals to R, it's nothing but unknown resistance value X. X value already we got, that is R L1 by 100 minus L1. Substituting here R L1 by 100 minus L1 and pi R square by L. R is the radius of the wire. We can calculate this radius of the wire by using of screw gauge, and L is the length of the manganese wire. By using of this formula, we calculate or we can get the value of resistivity or specific resistance of the given manganese wire in ohm meter. Ohm meter is a unit. Okay. So thank you. Subscribe and share my channel. Thank you all. Have a nice day.